a really, really poor assumption that both Grandview and Bexley are large high schools instead of the small schools that we are. But we're doing that just kind of so because they kind of need to be for this example to kind of work itself out. But we're just going to pretend, okay? All right, and so let's go ahead and say that there are two schools, Grandview and Bexley, where 70% did their homework last night at Grandview. So are you guys cool if I call that P Grandview and call it 0.7? Okay, and at Bexley, that proportion is only 50%. All right, then let's see. Mr. Stork is going to take a sample of 100 students from Grandview. So that would be, and the N for Grandview equals 100. And so the N for Bexley would be 200. So what we talked about yesterday was like if I take a random sample from one population, one sample from one population. Today what we're going to talk about is taking two different samples from two different populations and comparing them. Is everybody with me? So what I want to start with are, what are some possible P hats we could get from Grandview? If I take that sample of 100 kids, is it going to be exactly 70 out of 100? Probably not. We could get a P hat of 0.68. We could get a P hat of 0.71. We could get a P hat of 0.73. Right? These are all just possible P hats that we get from our sample, like from the Grandview group. Okay? So what I want to know, guys, are if I just look at the Grandviews, how could we describe the distribution of all the possible P hats we could get from Grandview? You guys catch my drift here? Let's start with, will those P hats from Grandview be approximately normal? How do we check to see if something is normally distributed? For the P hats, what was our rule from yesterday?
The N minus the P.
We would do NP and 1 minus P and say, are they greater than or equal to 10? Okay? So if I do that for this group, for Grandview, right now, this would be 100 times 0.7, which is 70, and 100 times 0.3, which is 30. Are those greater than or equal to 10? Does that work? So we can say for Grandview, the P hats are approximately normal. What is the mean of the P hats for Grandview going to be? 0.7. It's just going to match that population mean. What about the standard deviation of those P hats for Grandview? Big fancy formula, but we're going to do 0.7 times 0.3 divided by 100, a formula that will be provided to you. Okay, so you don't even, I don't know what that works out to be. I could guess, but I would love some help.
0.046.
Cool. So far, anything crazy? All right, now, what are some possible P hats from Bexley? If the actual percentage at Bexley is 50%, what are some possible percentages?
0.48.
0.48. What else? 0.57. Sure?
0.51.
You get the basic premise. What about 0.5? Is it possible that it's 0.5? Sure.
Yeah.
Sure. Okay. All are possibilities. All right. Now, can we do the shape center spread for Bexley? Let's see. NP would become 200 times 0.5. N1 minus P would be 200 times 0.5. Both of those are equal to 100, y'all. That's greater than or equal to 10. So the Bexley percentages are approximately normal. What about the mean of those P hats for Bexley? What would that be? 0.5. And the standard deviation would be the square root of 0.5 times 0.5 over 200.
Whenever she comes in, I'm like, because there's so many kids in my class, but it's equal chance that it could be just coming college.
Did you guys get 0.035? Is that what we got? I think. All right. Guys, why was the Bexley standard deviation smaller than the Grandview standard deviation? The bigger sample size. Okay, for sure. All right. Now, you guys. When I have two different groups that I'm comparing, okay, whenever we make a comparison, what we are really doing is saying what are the differences between the two. Okay? What math operation goes with difference? Subtraction. So, what is a possible difference between my Grandview fraction and my Bexley fraction? You know what I'm going to do? Since we came up with possible samples, if Grandview had 68% and Bexley had 48%, what would the difference be? It would be 0.2, yeah? What if it was 71 and 57? What would that be? 0.24? 0.14? I think it's 0.14. What if it was 73 and 51? I'm just doing the ones that you guys came up with, yeah? That would be 0.22. Did you guys kind of catch my drift here? And so what if I started making a graph of those differences? Okay? So each difference would be each point on this dot plot would be a difference between two different samples. Let's start with, what would the mean of that graph be? In this case, it would be 0.2. How'd you get 0.2, Blake? We already said that the mean of Grandview is 0.7, the mean of Bexley is 0.5. So overall, the mean of the differences between Grandview and Bexley would be 0.2. And if we look, let's see, we have a 0.2 right here. That was one of our possible differences that we could get. Or 0.22. Or 0.14 would be a little bit more down this way. And these are just, I take two random samples and subtract their percents. Okay? All right. What about the shape of that graph? It's going to be normal because since both of my initial distributions are normal, their differences are also going to be normal. Okay. Lastly, What is the standard deviation of those differences going to be? Thoughts?
Would you just do 0.046 minus 0.035?
That one, so this, no, because we never, ever, ever, ever subtract standard deviations. Just because we're subtracting the points, we have all the uncertainty of Grandview and all the uncertainty of Bexley coming up with these differences. We have more uncertainty. So this is when we would do, no matter what, we do the square root of, because standard deviations always have a square root, right? Okay, we're going to do the 0.046 squared plus the 0.035 squared. This is when we do that Pythagorean theorem type thing. I don't know what the answer is to that. 0.058 seems appropriately. How we feeling? Okay? All right. So what happened? 200 students from Bexley end up with specific rules for the sampling distribution of p hat 1 minus p hat 2, but it's really not new rules. Okay? All that happens here is that we're just doing everything twice, essentially. Okay? So for the shape, like the difference between two sample p hats will be approximately normal. I should say the differences between two different samples will be approximately normal if that NPN1 minus P greater than or equal to 10 is true for both groups. Okay? And then the mean of P hat 1 minus P hat 2 is always equal to P1 minus P2. And the standard deviation of P hat 1 minus P hat 2. Well, essentially what you're going to have is, that's not right at all. Well, if it was just P hat, we would do P1 minus P over N. Now what we're going to do is P1, 1 minus P1 all over N1. You're going to have a fraction for each sample. One for your first group, and then again for your second group. Are we doing okay? Right. So let's do this next example, and then we're done. Okay? All right, help me out, y'all. What are some important pieces of information we might want to write down here? The P for the statistics group is 0.65. Cool. What else?
P for the calculus group is 0.76.
Okay? And then let's see. N for statistics is 35, and for calc is 40. All right. So if I do for this group, guys, if I do that NP, N1 minus P for the statistics group, okay, is that approximately normal? Will they be approximately approximately normal? What should we do? 35 times 0.65, 35 times 0.35, and just tell me what you guys get.
For the times points, it's like
22.75. Cool, so that means this is a 0.25. I think it's going to be 12.25. So for the statistics group, we can say that the p-hats are approximately normal. What about for calc?
It's not
Just tell me what you're getting.
9.6. Well, for the 40 times 0.24, and then for the 40 times 0.76, I got 30.4.
Technically, not normal. Because 9.6 is less than 10. But for now, we're just going to call this close enough. Okay. Some people use 5 as the cutoff instead of 10. We're going to, because we're subtracting with another normal distribution, it's going to be close enough. Okay? All right. So, you guys, if I do normal minus close to normal, are you guys cool with saying that the shape of p hat s minus p hat c will be approximately normal? And what will the mean of the differences be? We're doing statistics minus calc. What's that mean gonna be, y'all? Negative what? So we would do 0.65 minus 0.76, which is negative 0.11. All right, what about the standard deviation? Big fancy formula. I kind of make myself some room here. I don't know what the answer is, though. And imagine it's a relatively high amount of percentage points, like 10 or 11%.
0.105.
Pretty small sample sizes comparatively. Okay. Okay, for percents. All right, y'all. So next, let's go ahead and draw a picture of that. And if I want to know what is the probability that the difference is of statistics minus calculus is less than negative 0.02. Where would that negative 0.02 be? Would it be to the right or to the left of that negative 0.11? To the right, because negative numbers count backwards. So we got to be really careful now that negatives are in the realm of our existence, right? Okay. And what is that probability, y'all? I would imagine it's under 84%.
0.804.
0.804.
How would you put this in?
Normal CDI.
Okay.
So would it be surprising if that happened? If we got a value of negative 0.02 or less? Is that surprising at all? Not at all. Not surprising. You would expect that to happen. And that's all I got.